Until the end, that's fine too. And I will do my best. What time do I need to be done?
Yeah, like 1:15.
Okay, and I will, okay.
Thank you.
I will keep an eye out for that. A little bit about me. My work spans a wide array of different things that we do for visualization and data analysis. Everything from analyzing large amounts of text. So this is actually one of the examples we'll look at later during this talk. It visualizes all of English Wikipedia, so 4.6 million documents roughly. We're very interested recently in helping people build machine learning models that are not formally trained data scientists. So the idea that while data scientists are a little easier, you'll hear about how we try to mitigate cognitive bias in this talk here and some of the techniques we've done for that. Ability to allow people to do things, but it's actually very difficult because there's a lot for people to do in a pretty high level description of how we go from data, way over here, right, all the way to pick which model that you're actually going to use, right? So we have a lot of things about just specifying the problem, right? Is it clustering? Is it regression? Is it prediction? Is it collaborative filtering? Community detection? Graph edge detection, right? There's a whole bunch of things you can use all the way over here to finally saying, well, okay, I ran my model generator and generated 100 models. Which one do I use? Right? They all have 99% accuracy, but they're all different in specific ways. So what do I do? And my lab has done a lot of work in that space, roughly organized by this. We have systems that help people generate sort of domain problems down to machine learning problems. So like the coffee shop example, all the way over to sort of allowing people to actually compare different models and see which one works better for a specific task. Bar chart that shows, I think it's like server usage over time, but it's not really that important what it shows. But what you can see is that, you know, this blue process was using more memory on the server earlier on, and then it went away, and now this yellow one used more towards the end. And this works well because it leverages our perceptual system, our cognitive system, and as many folks in literature have said, I think it was Don Norman is one of the earliest, people cannot help but be furious sense makers. We see something, anything, right, even if you just watch people in the town, and we can't help but try to figure out what's going on, right? It's just how we are as people. And so visualization is great because it actually does that, right? You're wondering, well, what caused this to go down, and what caused that to go up? And I'm very curious. Right? And Fire, but if you've ever used Tableau or any of the other popular visualization systems, they very much look like this. And it's interesting in the sense that the visualization often gets smaller and smaller, and the control panels and interactions get bigger and bigger. Why is that? It's because as soon as you see a data visually, you oftentimes start asking questions. You're like, answer questions, you want to ask questions, and interaction lets you do that, right? So that's the importance of user interaction for data visualization. So let's move on. Relative easy one, but I want to move on to something slightly more analytic driven, right? So if you think about visualization as visualizing your data, visual analytics often is visualizing the result of some sort of analytic or computational model. In this case, dimension reduction. So here's an early prototype. This did not come from my lab. This came from the University of North Carolina in Charlotte, from Remco Chang and some of his colleagues. And it uses simple linear dimension reduction principal component analysis in order to help a group of biologists visualize the similarities in their genomes, right? And so this is very high dimensional data. Here you see some of the dimensions. And basically, right, if you think about PCA, it's taking your high dimensional data, shining a flashlight through it, and whatever the dots are, the shadow that is made, that's your projection, right? Well, there's things you can control there, right? You can say, well, which dimension do I care more about than the other, right? They're maybe not all equal, some are more important than others, and you can do that. And further, right, he had this nice ability to let people choose which principal component to map onto the X or Y axis, right? You have two axes here that make up the scatter plot. Yeah, and I'll do it. So typically, this is where I ask the audience to a show of hands, who can explain or know the difference between choosing the first or third principal component of a PCA decomposition? Exactly the response I usually get, right? And this leads me back to that usable part of what I talked about for interaction. And Remco Chang is a good colleague of mine, actually a very good friend of mine as well. And he admits even in the paper when he published this back in 2005 maybe or so, users had no idea what they were doing here, right? Choosing, you know, which principal component and how do I do the weighting, and right, what they understood was their data, right? This piece here. They understood, oh, this sample here is very similar to this sample here and less similar to here, right? But they don't understand these model parameters and principal components, right, and all this stuff. So, right, at a high level, if you look at what interaction means in this tool, it actually means, you know, users must adjust this stuff, right, the weighting or the principal component, to see a different representation, right? You adjust the input parameters, run the algorithm, and then out comes a new visualization. Well, explore what's happening. I guess real quick, I should say, here I focused a lot when I talked about this on the visual and the interactive way that this is actually portrayed. Underlying this is, whoa.
Sorry.
Topic model developed from some colleagues of mine at Georgia Tech that uses non-negative matrix factorization in order to determine the likelihood that certain terms are close to each other, right? And you can imagine a very different user interface here, right? Where I say, oh, please help adjust this non-negative matrix and figure out which terms you want to linearly combine and which ones you want to orthogonally, right? And it's like, you could design that interface, right? You could just do it. But it would be a very different user experience, and one that likely will not get as much use as going in, and we have this actually up on a large, it's kind of like that, like a touch screen thing. And you see people, you know, even times we have sort of high school and middle school kids come through, and they love going up and dragging words around and making some bigger and smaller. And it's actually quite engaging user experience, as opposed to, right, having this be very, very small, and then a whole bunch of control panels everywhere that allow people to do stuff where it'd probably be a lot harder for them to know what they're doing.
CSE are the degrees. What are they?
Yes. So at Georgia Tech, we have computing as a college, and so we have schools under it. So we have 3 schools, and they are amazingly confusingly named. One of them is the School of Computer Science, which has a lot of the CS theory and those and sort of compilers and programming languages. The other one is the School of CS.
How do you test the usability of the visualization? You get to see the user play with the visualization, and you do interviews, or
Yeah. So there's a number of ways that we test the usability, but I think the most common one is what you described. We have a data set, we have a set of tasks, and we ask users that meet the criteria of the users that we try to emulate to come in and to use those tools and to perform those tasks. And then there are the more traditional metrics you can measure, like how accurate were they? Were they able to do the task or not? And how long did it take them? Right? Was it faster than it was before? So we might compare it to some other tool that they're using now, or maybe just a manual way if they don't have a tool. But you also get out of that a lot of other metrics, things like engagement, things like memorability. That's a new one that we're seeing used quite a bit, where the goal might not be to say, oh, you're 3 seconds faster doing this thing, where it's like, well, is that really that relevant? In some cases, yes, you need an answer very, very quickly. But in other cases, I don't know, I don't think 3 seconds matters. But what might matter is if I ask you again a week from now about what you found, are you able to remember it a lot better? And personally, I find those kinds of metrics much more interesting, much more impactful than saying, oh, you were 3 seconds faster. That's just me.
First of all, when you talk about the model of the cars, I'm curious about which program did you use to build it?
Yeah, so a lot of our tools are built sort of, we typically have a Python backend. So that's what we use to basically retain and parse all of our data that we're using. And if we're using things that have to do with heavy analytics, we'll use sklearn as the library in Python that allows us to do a lot of these things. If we're using even more mathematically heavy things, like the stuff that Hannah does, all her stuff starts out in MATLAB and then gets converted either to C++ or Python. So on the front end though, right, we then use a lot of web-based technologies. So we use HTML, CSS, D3 is the popular one that we use. And then we use certain sort of interface libraries on top of that, things like React or Angular or I think it comes in waves. This is not the first time. So I should acknowledge, right now VR and AR are very popular. The cost of these devices is coming down. The ease of developing for these devices is increasing. So we're starting to see many more of them than we saw maybe 5 years ago. But it's not the first time that we've sort of seen these VR, AR devices sort of pop up. I remember pictures. There's a professor that does AR and VR research at Georgia Tech, and his lab is actually literally right below mine. And so I often walk down there and hang out, and there's pictures hanging up there where he was at the time very excited, I don't know, 20 years ago or something about VR, and he had this backpack that he carried around with this thing that looked like a helmet on his head. And the thing in the backpack was not only a computer, it was like a car battery, right? Because he had to power the thing. Right? And so I think that you're seeing a lot of the current use of VR and AR be because you no longer have to do that. Unfortunately, I still think that especially for visualization, you struggle with some of the interaction challenges that you used to have as well, right? How do you rotate? How do you pan around? How do you do all these things on top of right? I made the joke about 1 pixel at a time, but resolution really matters for visualization.